This comes in your exam. Don't skip this. +2 Chemistry, Solutions chapter, explained in just 5 minutes. If you want to score easy marks, this is the most important revision you need right now. Henry's law, solubility of gases, mole fraction, vapor pressure, everything made simple and fast. So stay till the end. This might be the difference between full marks and losing marks. Let's get started. +2 Chemistry, Solutions. Properties of a solution depend on composition and concentration. Fluoride example. 1 part per million prevents tooth decay. 1.5 parts per million causes teeth to become mottled. Very high concentration of fluoride is poisonous. Homogeneous mixture. Mixtures having the same properties throughout. Uniform composition. Solution. A homogeneous mixture of 2 or more substances. Uniform composition and properties throughout. Components of a solution. Solute. Substance dissolved. Solvent. Component present in excess. Remember, solvent is the component present in excess in a solution. Types of solutions? 3 types, 9 combinations, easy examples. Gaseous solutions, solute, gas, solvent, gas. Example, mixture of oxygen and carbon dioxide. Solute, liquid, solvent, gas. Example, chloroform mixed with nitrogen gas, water vapor and air. Solute, solid, solvent, gas. Example, camphor and nitrogen gas, naphthalene and air. Liquid solutions, solute, gas, solvent, liquid. Example, oxygen dissolved in water, soda water. Solute, liquid, solvent, liquid. Example, alcohol dissolved in water, dilute acids and alkalis. Solute, solid, solvent, liquid. Example, salt in water, glucose in water. Solid solutions, solute, gas, solvent, solid. Example, hydrogen and palladium, platinum, nickel. Solute, liquid, solvent, solid. Example, amalgam of mercury with sodium. Solute, solid, solvent, solid. Example, gold ornaments, alloys of metals. Expressing concentrations of solutions. Mass percentage, weight by weight percentage. Mass percentage equals mass of the component in the solution divided by total mass of the solution, multiplied by 100. Example, 10% glucose in water by mass means 10 grams glucose in 90 grams water. Total mass equals 100 grams. One-word answer, commercial bleaching solution, 3.62% of sodium hypochlorite in water. That is, 3.62 grams sodium hypochlorite in 96.38 grams water. Volume percentage, volume by volume, used when both components are liquid. Volume percentage of a component equals volume of the component divided by total volume, multiplied by 100. Remember, volume percentage is always volume by volume. Both components must be in liquid state. Example, 35% ethylene glycol used as an antifreeze in automobiles for cooling the engine. It lowers the freezing point of water to minus 17.6 degrees Celsius. That is, 35 milliliters ethylene glycol and 65 milliliters water. Mass by volume percentage, weight by volume. Mass of solute in 100 milliliters of the solution, used in medicine and pharmacy. ppm, parts per million. When solute is present in minute quantities, ppm equals number of parts of the component divided by total number of parts of all the components, multiplied by 10 to the power 6. Also, it can be expressed as mass to mass, volume to volume, mass to volume percentage. Example, the amount of dissolved oxygen can be expressed as 5.8 parts per million, means 5.8 grams of oxygen in 10 to the power 6 parts of seawater. Mole fraction, X, it is a ratio. X equals number of moles of one component divided by total number of moles of all components. For a binary mixture of 2 components A and B, XA equals Na divided by Na plus Nb. XB equals Nb divided by Na plus Nb. Na is the number of moles of A. Nb is the number of moles of B. Na plus Nb is the total number of moles of A and B. Sum of mole fractions of all the components in a solution is always unity. That is, x1 plus x2 plus dot 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 plus x I equals 1. Molarity, M. Number of moles of solute per liter of the solution. M equals number of moles of solute divided by volume of solution in liters. Number of moles equals given mass divided by molar mass. Example: 0.25 molar sodium hydroxide means 0.25 moles sodium hydroxide in 1 liter solution. Molality, M. Number of moles of solute per kilogram of the solvent. M equals number of moles of solute divided by mass of solvent in kilogram. Example: 1 m potassium chloride means 1 mole potassium chloride in 1 kilogram water.